Scientists have found explanations for why some planets are decreasing in size in a groundbreaking study that could solve one of space's long-standing mysteries. For this they used data from NASA's retired Kepler Space Telescope. Planetary bodies that have been found outside the solar system are called exoplanets. Over 5,000 exoplanets have been found so far. According to the research scientist, it is possible that certain subneptune planets' cores are pushing their atmospheres away, which means that the planet's size decreases. Experts have identified a number of crucial components that contribute to the contraction of certain planets through exhaustive research and data analysis. 1. One significant factor is the cooling of planetary interiors. Planets, like all other celestial objects, produce heat. Over time, the planet's inside cools as this heat evaporates into space. Material of a planet shrinks as it cools. When the ratio of surface area to volume is higher, this cooling process is most evident in smaller planets. 2. Internal heat loss due to various geological processes is another contributing factor. Internal activity includes volcanic eruptions and tectonic movements. These processes release energy, cooling the planet. When the inside of a planet cools, its size shrinks. 3. The tendency of a planet to shrink is also influenced by its crust and mantle. When planets are made up of materials that can easily compress under pressure, they are more likely to contract. A planet's susceptibility to shrinking over time is affected by its type of minerals and abundance in its composition. These observations and measurements from space missions and telescopes have provided useful information to support these conclusions. Scientists have analyzed various planets' surface features, seismic activity, and overall dimensions by comparing them to models and simulations. The scientific community is now more confident in finding out why certain planets are decreasing because of the convergence of these observations and theoretical predictions. Various exoplanets can be found in the universe, from small, rocky worlds to massive gas giants. Astronomers, on the other hand, have discovered a surprising lack of planets with diameters that are 1.5 to 2 times that of Earth, creating a size gap between rocky super-Earths and gaseous subneptunes. Scientists suggest that a subneptune may shrink to super-Earth size if it lacks enough mass to keep its atmosphere. This atmospheric loss is thought to be caused by two main mechanisms: core-powered photoevaporation and mass loss. The former is supported by new evidence, which shows how radiation from a planet's hot core slowly pushes the atmosphere out. When a star's intense radiation strips away a planet's atmosphere, it's called photoevaporation. This process is similar to melting an ice cube with a hairdryer. Core-powered mass loss is most likely to occur within a billion years, but photoevaporation is thought to occur within the first 100 million years of a planet's existence. To investigate these theories, scientists' team looked at data from the K2 mission. They discovered that nearly all stars in these clusters still have subneptune planets, indicating that their atmospheres have not been damaged by photoevaporation. The most plausible explanation for the size gap that was observed is core-powered mass loss. Understanding how atmospheres on exoplanets have evolved can help us figure out how far away distant worlds may have people living.